So for section 1.2, we are only going to talk about symmetry, and we will discuss 3 types of symmetry in this section. So the first type of symmetry is something that is symmetric with respect to the x-axis. That's going to happen if every point xy has a corresponding point with the same x but a negative y also on the graph. So I'll give you an example. So you probably haven't seen a graph like this before, sideways parabola. In this one, I have the equation x equals y squared. In this one, for example, 4, 2 is on the graph. And in addition to that, 4, -2 is on the graph. So symmetry with respect to the x-axis is actually the least common because anything that has that type of symmetry is not going to be a function. So they're not very common, but you occasionally see them. So our next type of symmetry is something that is symmetric with respect to the y-axis. That's going to happen if every xy on the graph has a corresponding point with the same y value, but the x value is the opposite sign. And a good example of that is if you have something like y equals 4 minus x squared. That is going to be a parabola, an upside down parabola actually. In this one, for example, the point 1, 3 is on the graph. In addition to that, the point -1, 3 is also on the graph. So that's symmetric about the y-axis, or with respect to the y-axis. And you can kind of see that for both of these ones. If you were to chop this graph in half at the y-axis, it'd be like there was a mirror image of each side on the other side. The same thing happens with symmetric about the x-axis, or with respect to the x-axis. So our last type of symmetry is symmetric with respect to the origin. That is going to happen if for every point xy on the graph, -x, -y is also on the graph. And I will give you an example here also. So let's say we have the graph of y equals x cubed minus 4x. That actually looks kind of like this. It has, sorry, my graph is not quite perfect. It has x-intercepts at -2, 0, and +2. In addition, it will have a maximum point and a minimum point, and the minimum point is at 1, -3. The maximum point is at -1, +3. So you'll notice that the x and the y values of those have exact opposite signs. Another way, so that's how we can kind of tell it's symmetric about the origin. The other way we can kind of tell is if you were to draw the line, it's hard, you have to use your imagination here. If you draw the line y equals x and you flip around that line, like you kind of fold it over and then you fold it again, you can also think of it as turning around 180 degrees. You will get the exact same thing on both sides. So if you kind of shift this, each side of that y equals x line around 180 degrees, you will get that. So symmetry about the y-axis and the origin are actually going to become very important later on, but for now, these are the only problems we're really going to worry about for these. You're just going to need to identify them for now.